Hi, in this video what we're going to do is discuss a common form of argumentation called argument from elimination. Turns out it's pretty intuitive informally speaking, but it's much more difficult to represent in the Fitch style system. So what we're going to do is first discuss it in its intuitive form, in the informal form, and after doing that we'll then move over to the Fitch computer program and I'll show you how to represent argument from elimination in the Fitch computer program. So let's turn to doing that.
All right, so let's take a look at this argument from elimination that is given to us informally. The first premise that we get is A is a cube, D is large, or C and E are the same shape. So if we get to accept this as being true, and it's a premise, so we do get to accept it as being true, all it tells us is that at least one of these is true. But we don't know which one of those is true. Maybe two of them are true, maybe three of them is true. All we know is at least one of them is true. All right, we come down to the next set of information, and it says, however, we can see that A isn't a cube. Well, looking at the first disjunct of the disjunction above, it says that A is a cube. So if it's true that A isn't a cube, then this must be false. It's not what is making that disjunction true. And then the information goes below continues saying, while C is a tetrahedron, E is a dodecahedron. And we know that C being a tetrahedron and E being a dodecahedron prevents those from being the same shape. So from these two bits of information, we can infer that it's not the case that C and E are the same shape. And going back up to our disjunction then and looking at the last disjunct, it says that C and E are the same shape. So if it's true that it's not the case that C and E are the same shape, then this can't be what's making our disjunction true. So notice then that there's only one disjunct left over that could make the disjunction true. So if we get to accept it to be true, the disjunction, then that disjunct has to be true. And indeed, that's what we infer here. It must be the case then that D is large. Pretty intuitive. Basically, starting with the disjunction, it gives you a set of options, and then we get some more information that eliminates all but one option. So it doesn't matter whether we have a disjunction with two disjuncts, a disjunction with three disjuncts, a disjunction with four disjuncts, so on and so forth. As long as we can eliminate all but one option, that last option, that last disjunct, must be true. And that's how argument from elimination proceeds. Now, while it's very intuitive informally, the way to represent it in the Fitch style system is actually a little bit more complicated. It's not as intuitive. So what I want to do now is turn to the Fitch computer program so that I can show you how to represent this in the Fitch style system. Let's turn to doing that. Right, so here we have the very same proof that we were just looking at informally, only now it's been put in FOL. So the first premise here says that either A is a cube, D is large, or C is the same shape as E. And then our second premise tells us both. It's not the case that A is a cube and both C is a tetrahedron and E is a dodecahedron. So looking at one, since it's a disjunction, and a disjunction is true if and only if at least one of its disjuncts is true, then I know that at least one of these disjuncts is true. And then 2, since it's a conjunction, and a conjunction is true if and only if all of its conjuncts is true, I know that it's not the case that A is a cube is true, and I know that both C is a tetrahedron and E is a dodecahedron is true. And since this conjunct itself is a conjunction, I know that C is a tetrahedron must be true individually, and I know that E is a dodecahedron must be true individually. And then looking at 1 and 2, since it's not the case that A is a cube must be true, I know that this disjunct must be false. And because I know that C is a tetrahedron must be true, and E is a dodecahedron must be true, and I know that we can infer from that that C and E are not the same shape, then I know that this disjunct must be false. It cannot be true. And since 2 of the 3 disjuncts must be false, the one that has not been falsified, given premise 1, must be true. So D is large must be true. And that is in fact what we're trying to prove. All right, so let's start working on the proof. Turns out there's actually multiple ways in which we can provide a good proof here, a proof that shows that given 1 and 2, D must be large. But what I'm going to do is I'm going to try to mimic as much as possible. I won't be able to do it completely, but I'm going to try to mimic as much as possible the way that we proceeded in the informal proof. All right, and the first thing that we did in the informal proof is point out that A isn't a cube. All right, and we can grab that out by using conjunction elimination on 2. And then I pointed out that the fact that A isn't a cube means that this disjunct must be false. So that was one of our options. And the way that we can think about showing that disjunct as being false is by pointing out that they contradict one another. So we go to contradiction introduction. Since this occurs before the subproof and it's not within the subproof, we get to accept it to be true even inside of this subproof. 4 and 3 take the form of P and not the case P, so I can apply contradiction introduction to it and get our contradiction rather. All right, so we can think about that as showing that the disjunct A is a cube is false. Okay, then the next thing that we did is we talked about C is a tetrahedron and E is a dodecahedron. And we can pull that out from 2. Oops. By using conjunction elimination. Okay, and we were talking about how if C is a tetrahedron and E is a dodecahedron, then C and E cannot be the same shape. Now, I'm going to have to rely on the meaning of the premises and the constraints of Tarski's world in order to infer that it's not the case that C and E are the same shape. Since AnaCon typically only allows you to use 2 steps at a time, then what I'm going to have to do is break this conjunction apart and pull out both C as a tetrahedron and E as a dodecahedron. So I can do that with conjunction elimination. Citing 6, that's where that's coming from. And E is a dodecahedron. And that will be coming from 6 as well. And now, by AnaCon, I can infer that it's not the case that C and E are the same shape. Why? Because 7 and 8 are different shapes. Now that I have that it's not the case that C is the same shape as E, coming back up to our disjunction, I see that that falsifies our last disjunct. So now I pull out that option. And in the same way as up here, we got a contradiction. We're going to get a contradiction here from 9 and 10. So we use contradiction introduction. We have P and not the case P as our form. And then we pointed out that that leaves us with only one option left in our disjunction, namely that D is large. Okay, so now what we're going to do is we're going to depart from the informal reasoning. Now we have to do some tweaking in order to get this to work. If I can, in each of these subproofs, get that D is large, so here, so 13, 14, and 6, then by disjunction elimination, I'll be able to infer D is large, which is the right result for given the argument and argument from elimination. And it turns out that we can do that because since we have inferred a contradiction in two of those options, we can, by contradiction elimination, infer whatever we want. Well, in this case, it makes sense for us to infer that D is large so that we can make use of disjunction elimination. So we will see that by contradiction elimination, that'll work out. We can infer that D is large. We're going to be able to do the very same thing at step 13. So we apply contradiction elimination. We cite the contradiction. Maybe we cite it. There we go. And since our third option just is D is large, there's nothing more that we need to do. If you want to, you could reiterate D is large, but you actually don't have to. So now we can use disjunction elimination to infer that D is large. What we have to do is cite the disjunction that gave us the various options in question. That was premise 1. Then we have to cite all of the options leading to the very same sentence. So this subproof represents one option that led us to D is large. This represents the second option that eventually led us to D is large. And here's our third option, which just states that D is large. So that gives us D is large by disjunction elimination, and we see that the proof checks out. All right, so that is how we do argument from elimination in Fitch. Just to recap, the general features that are important here is that when we go through all but one option, we generate a contradiction, which then allows us to infer the disjunct that doesn't get falsified. In this case, that was D is large. So we got to do that here. We got our contradiction here. And then that's how we pull out that D is large must be true. All right, before concluding this video, I want to look at one more argument from elimination. This one is a much more simple case, but the reason why I want to go over this one is we're going to use AnaCon to infer the contradiction instead of using contradiction introduction. So our first premise says that either A is a cube or B is large, and the second premise tells us that A is a dodecahedron. Of course, if A is a dodecahedron, it cannot be the case that A is large. It's not going to be the case that A is a cube. So we're going to be able to infer that B is large. All right, so let's take the first case, which is that A is a cube. And because A is actually a dodecahedron by premise 2, what I can do then is use AnaCon to infer a contradiction. Notice that it won't work to use contradiction introduction because 2 and 3 do not take the form P and not the case P. It can only be done by the meaning of the predicates, which is what AnaCon is sensitive to. Okay? Of course, the second case is B is large. And since given 1 and 2, it's got to be the case that B is large. That's what we want to infer. By contradiction elimination, I can infer anything that I want. Of course, I want to infer that B is large so that I can use disjunction elimination to infer outside of these subproofs. And I can use disjunction elimination because we have our disjuncts with the options A is a cube and B is large. And then from A is a cube, we can infer that B is large. And from B is large, of course, we can infer that B is large. That is, we can infer the very same proposition from either of the options. In fact, from both of the options. So then we find disjunction elimination. We have to cite the disjunction from which we're getting the options from. And then we have to cite that option, in this case a is the cube, that it actually leads to the same sentence as all the other options, in this case b is large. And then we have to cite the other option that leads to the same sentence, in this case again, that's b is large, and we are able to infer that b is large.
All right, that wraps up this video on argument from elimination and how to represent that in the Fitch style system. I hope it helps.